Let us start with the spontaneous and non-spontaneous processes. So what are spontaneous processes? Spontaneous processes are those processes which either proceed by themselves or require some initiation to proceed. So the processes which proceed by themselves or require some initiation to proceed. Once they are initiated, they will proceed till end. So examples are H2O solid changing into H2O liquid. This is a spontaneous process. H2O liquid changing into H2O vapors. Then sugar dissolved in water. It will dissolve completely. Dissolved sugar in water. That is sugar solution. Then some processes they need initiation. For example, coke is when ignited with oxygen, it produces CO2 gas. It is a spontaneous process. So some of the processes they are spontaneous, they don't need initiation, like H2O solid itself changes into liquid by taking some energy from the surrounding. Similarly, H2O liquid changes into vapors, that is evaporation of water from the ponds and lakes. Then the combination of NO and with O2 to give you 2NO2. This is also a process which do not need initiation, but this process needs initiation. So once carbon is ignited, it will burn indefinitely till whole of the carbon is ignited. Now what are the factors which affect spontaneity? First factor is minimum energy factor. It is the natural tendency on the part of every system to acquire the state of minimum energy, and in order to achieve that, the reaction becomes spontaneous in nature. Then we have the maximum randomness factor. It is another tendency on the part of every system to acquire the state of maximum randomness. Both of these factors, they are operating in the opposite direction, they are opposite to each other. The resultant of these two factors determines the spontaneity of the reaction. For example, considering the reaction 1, here we are having one solid, one gas, here one is gas, so 1 minus 1 gas molecules, they are automatically balanced. Still, this side does not have any solid material, therefore spontaneity increases on this side. So randomness factor, it favors this reaction, and minimum energy factor, that also favors this reaction. So driving force in this case, both are trying to bring the process in the forward direction. So this force is positive. This is called as driving force, and process becomes spontaneous. Now considering this process, H2O solid to H2O liquid. Now when we come from this to this state, randomness factor favors this process, but minimum energy factor does not favor, because energy of liquid water is more as compared to solid water. So minimum energy was acting in this direction. Driving force will be forward force minus backward force. This is positive, only then reaction is spontaneous. So these are the spontaneous process and the factors which are affecting spontaneity of the reaction. Now we come to the other factor, they are the non-spontaneous processes. Now what are non-spontaneous processes? Are those processes which neither proceed by themselves nor proceed on initiation. They are called as non-spontaneous processes. So what are non-spontaneous processes? They do not proceed by themselves, nor they proceed on initiation. They are called as non-spontaneous process. So question number 2 is, what are non-spontaneous process? The processes which neither proceed by themselves nor proceed by initiation. For example, sand does not dissolve in water. This is a non-spontaneous process. Water does not flow from plains to hills. This is a non-spontaneous process. So such processes which neither proceed by themselves nor proceed on initiation, they are called as non-spontaneous process. In such cases, the driving force that comes out to be the negative in this case. So sand does not dissolve in water, randomness factor does not favor it all, and minimum energy factor that also does not favor. So driving force in both of these processes is negative. That's why these processes, they become non-spontaneous in nature. So after spontaneous and non-spontaneous process, we come to the another question number 3. Give all the statements of second law of thermodynamics. So number of statements by different scientists, they are given by for second law of thermodynamics. First statement was given by Kelvin. This is known by his name as Kelvin statement. Now what does Kelvin state? It is impossible by means of any perpetual machine which can inanimate material agency or perpetual machine to derive mechanical effort from any portion of the matter by cooling it below the temperature of the coldest of the surrounding body. So we cannot draw mechanical effort by cooling a body below the coldest body of the surrounding. So that work cannot be obtained, or it is very difficult to derive mechanical effort from a system or from an inanimate material agency, from its any matter of the any portion of the matter by cooling it below the coldest surrounding coldest body. It is very difficult to bring the temperature below that coldest body, so we cannot draw any mechanical effort from this material agency. So Kelvin's statement is, it is impossible to draw mechanical effort from a body by cooling it just below the body, just below the temperature which is possessed by the coldest body in our universe. So we cannot convert that energy into work. Second was the statement of Clausius. Now Clausius gave the statement that it is impossible for self-acting machine unaided by any external agency to bring a body to a low to supply heat from a body at low temperature to body at high temperature. So this is Clausius' statement that heat cannot be transferred from a cold reservoir to hot reservoir. It will always flow from hot reservoir to cold reservoir. So this is Clausius statement. Then we have the Planck's statement. Then what is Planck's statement? It is impossible to construct a perpetual machine which will do work in a complete cycle and convert heat into equivalent amount of work without producing any change in the surrounding. So we cannot construct any perpetual machine, self-acting machine, which can produce work without producing any change in the surrounding. So whenever work is done, there are some changes. They are seen, they are appreciable in the surrounding also. So it is impossible to construct a perpetual machine which will do work in a complete cycle and convert heat into work. ऐसी कोई मशीन हम नहीं बना सकते जो कि हीट को वर्क में चेंज करें without bringing any change in the surrounding. For example, we are burning petrol in our petrol vehicles. The heat so produced, it is used to run the vehicle, but some of the energy produced by the combustion of petrol, that is lost to the surrounding, which increases the randomness of the surrounding. Therefore some of the heat is lost. So we have brought some change in the surrounding also when we are burning fuel in our vehicle to run that vehicle. This was the statement of Planck. Then we have the Ludwig statement. Now Ludwig's statement is nature tends to pass from less random state to more random state. नेचर में हमेशा हर सिस्टम की ये टेंडेंसी है, वो कम आज़ादी से ज़्यादा आज़ादी की ओर अपने आप को ट्रांसफ़र करना चाहता है. सो नाउ वी हैव कंबाइंड डेफिनेशन, जनरल डेफिनेशन ऑफ ऑल दीज. General definition is that in all the spontaneous process, the entropy of the universe is continuously increasing, or it happens in irreversible processes, because most of the processes they take place in an irreversible manner in our universe. So in all the spontaneous processes, entropy of the universe is continuously increasing, but energy content of the universe, they remain constant. Now let us give the mathematical proof for this law. So we are having a mathematical proof for this law. We know that delta S total of the universe, that is equal to of universe, it is equal to delta S of the system plus delta S of the surrounding, or we can put delta S total of universe, delta S system plus, now we can write in place of delta S surrounding, we can write delta H system but T, that is given minus sign, because the loss of heat by system, that will be gain of the heat by surrounding. So delta H system upon T. In place of delta S surrounding, we are putting delta H system upon T. We have converted both the terms in terms of system. So now we get delta S total, that is equal to delta S system, or we can write T delta S total of the universe, that will become T delta S system minus delta H system. So this is our equation now. or we can say T delta S total. That can also be written as delta H system minus T delta S system, or T delta S total of the universe, that is equal to delta G system. So T delta S total, that is equal to the T delta S delta G system, that is equal to delta G total. So they are given negative sign here when T delta S is brought to this. In this state we will be having this, we will be having negative sign here. So now we get that delta G negative is equal to minus T delta S total, or when free energy of the system is decreasing, then entropy of the universe is also in other words, it proves that in all the spontaneous process delta G is negative, delta S is positive. This is called as the second law of thermodynamics. So in all the spontaneous processes, when delta G is negative, then delta S would be positive. So this will be your like this delta G, and we can write over delta G system negative, this will be equal to T delta S total. From here we got the idea, when free energy of the system is decreasing, entropy it is continuously increasing. It is the general statement of the second law of thermodynamics. Then we come to the third law of thermodynamics. Define third law of thermodynamics. It states that at absolute zero, the entropy of absolute crystalline state of a substance is zero. Because at absolute zero, all types of the motions of the molecule they get ceased, all types of the activity of the molecule they are stopped. So we can say at absolute zero, the entropy of a perfect crystalline state of a substance, it is taken to be zero, or in other words we can say delta S at temperature T or St, it will be equal to 2.303 Cp log T. So Cp we know, specific heat of the substance at constant pressure. T is the temperature at which entropy change or entropy of the substance it is to be measured. So this is our third law of thermodynamics. Then we have very important definition. Question number 4, define enthalpy of solution. So enthalpy of solution, it is defined as the enthalpy change when 1 mole of the substance is dissolved in excess of the solvent, so that the further dilution does not produce any change in the enthalpy change in the heat. That's why this is called as enthalpy of solution. When 1 mole of the NaCl dissolved in water, we get NaCl aqueous. Then delta H in this case is around about 6.2 kilojoule per mole. Similarly, when KCl is dissolved in water, we get K positive aqueous plus Cl negative aqueous. Delta H is 17.5 kilojoules. Both of the reactions, they are endothermic in nature. So whenever the salt they dissolve in water, they absorb heat, their reactions are endothermic in nature. This concept is used in the crystallization of the ice cream by the ice cream generators, where the salt water mixture is kept around the ice cream mixture. It dissolves in salt, dissolves in water, produces heat, cools down the water, and this water in turn cools down the ice material, and ice material they get solidified in the end. So these are the few important topics which we were left from the chemical thermodynamics. So we have finished all these topics. So this is all about our current chemical thermodynamics. Tomorrow we'll take up with a fresh chapter that will be of chemical equilibrium. Thank you very much.